Hello everyone. In this case, we'll find the expressions coefficients beta and compressibility kappa using the Waals equation. So let's get started. With the Waals equation, it's this equation that we have over here, where we will find the expressions for the coefficients beta and the compressibility coefficient kappa. In order to do that, we need the expressions for the expressions given for those. In this case, we can observe that we need to compute the derivative of v with respect t and p, respectively. However, if we try to solve with the Waals equations for b, that would be very difficult. We can find any expression and then compute the derivative to find the coefficients. So to solve that problem, we'll use this expression here, this relation. This relation says that the derivative of t of v with respect to t is equal to 1 over the derivative of t with respect to v. This derivative we're able to compute it because it's easier to calculate instead this one. So if we want to compute this derivative, first of all, from the Waals equation, we need to solve for t, exactly what we had in this case. The only difference is we'll write it in different order. So we have RT equal to all the rest term. In this point, we're able to compute the derivative of t with respect to v. In this case, p will become constant. So we have it in here. We have r times the derivative of t with respect to v. In these times, we remember that r is a constant for the reason it can go out the derivative. So in here we have a product. So we need to use the rule of product for derivatives. We have p plus a over v squared plus v minus v times minus 2a over v cubed. So now just we need to simplify all this term. We need to solve this operation. So we must remember that we must to conserve the common denominator and do the corresponding operations to get this expression that we have in the numerator. Finally, r, which is multiplying the derivative, we can pass to the other side in division. Now that we have a term where we know what is the expression, the derivative of t with respect to v, we can use the relation that we mentioned before. The derivative of v with respect to t is equal to 1 over the derivative of t with respect to v. So we already know what this expression is. We have it in here. So we replace it and solve this operation. Finally, we'll get this term over here. So now that we know what the derivative of v with respect to t is, we can replace it in the expression for beta. So we have beta it's equal to 1 over v, this term it's exactly that we have in here, times the derivative of v with respect to t, but the derivative is this one. And we can simplify some terms. For example, this v and this v cube can be simplified in order to get this final expression. So we have that beta is equal to r times v squared over v times v squared plus a minus 2a times v minus b. So this is the final expression for beta. Likewise, for compressibility coefficient kappa, we can do exactly the same process. First of all, we need to compute the derivative of v with respect to t. So we know that it's equal to 1 over the derivative of p with respect to v. To compute the derivative of p with respect to v, we need to use one more time the Waals equation, but we need to solve for p instead of t, like the previous expression. So we'll compute the derivative with respect to v. In this case, t will become a constant. If we notice the derivative of this first term, we need to use the rule for division. And in the second part, we need to use an expression for a power algebraic expression. So now in here, we only choose the order, and we need to replace r and t, because we can't have this expression in terms of v and t. We need to use only one variable. So in order to replace this expression, we can use one more time the Waals equation and solve for r and t. Exactly what we wrote in this part. We already have an expression to replace this term over here. So in here we have the derivative replacing the expression rt by this expression over here. So now we need to simplify it. So we have the derivative of t with respect to v, and that is equal to all this term. We need to simplify it. In this case, I'll try to do the sum that we have here in the brackets, and we'll get this following expression. We'll continue simplifying, and we'll make the sum of dot fractions. Finally, we need to use only this expression that we saw before. The derivative of v with respect to p is equal to 1 over the derivative of p with respect to v. We have that expression over here. We have 1, the derivative of p over v, it's this expression that we compute before, and solving this fraction, we can get this following expression. So, if it is known that kappa is equal to minus 1 over v times the derivative of v with respect to p, we can replace this derivative over here by this last expression that we got. Thus, kappa will be equals to minus 1 over v times the derivative, but the derivative will obtain in the previous step, that it's this expression over here. Finally, we can simplify some terms and we'll get this expression. So this is the expression for the compressibility coefficients and beta coefficients using the van der Waals equation. Thank you very much for watching.